Hi guys. So let us solve this question. This question is from JEE Advanced 2020, paper 2. It's question number, let me see, it's question number 12. Yeah. So we have been given some information that this is basically SCR, the formula for SCR combination, and then after that, we have been given that there's a function of G, this is function of M and N, which looks like this. And after that, we have f of m comma n comma p. Okay, and you can see that here the limit is on p, which is starting from 0 up to m plus n. Same goes with here. Here the variable which is which takes the value is I. It's varying from 0 to p. Okay, so m and n are kind of constants here. Okay, and all the options are given in terms of g. That means we have to find out g of m comma n. Okay, so let's move on. So we have g of m comma n like this. We don't know what this expression is. We don't know is there a shortcut or something or a formula. There's nothing which strikes in the mind as of now. But just write it down and try to find out. Let's see if we can move further and find out something. Which we can use. Okay, so g of m comma n equals to summation of p equals to 0. Okay, yeah, p equals to 0, and it is moving from p equals to 0 to m plus n. Now what is f of m comma n comma p? That is something here. Okay, we cannot find out g of m comma n straight away. We have to find out first of all f of m comma n comma p. So what f of m comma n comma p is, summation of I equals to 0 up to p. What is MCI? That is nothing but m factorial upon m minus I factorial into I factorial. I hope everything is visible. Yeah. After that, we have n plus I CP, which is n plus I factorial upon p factorial into n plus I minus p whole factorial. Okay, now this thing is again multiplied by p plus n cp minus I. So if we write down p plus n factorial, we have p plus n factorial, okay, divided by p minus I factorial, obviously, and then difference of p plus n and p minus I will get n plus I factorial, right? N plus I factorial. Now interesting thing is that there are some cancellations. Let us do that. Okay, and that's it. We have nothing apart from that. Now think about it. We have summation going from for I from 0 to p. Then nothing is happening here. This is same. Nothing has happened to this term, right? But if you look at it, at this term, this is n plus I minus p factorial, p minus I factorial. Interesting thing is this, that let us just write down this. This is nothing but, okay. So this is nothing but MCI. Nothing has happened to this term, okay? But something is happening here. Just note, just think about it. If we take p plus n factorial upon p factorial outside, because there's no I involved in this, and you would say, so why you're doing this? What will happen to these two terms? There's something interesting in these two terms. Think about it. If somehow we had n factorial in the numerator, then this is nothing but n c p minus I, right? Because p minus I would be here, and n minus of p minus I is nothing but n plus I minus p. Okay, so what do we have here? If let us just rearrange these terms. I am putting p plus n factorial upon p factorial outside, n plus p factorial upon p factorial. This is outside because there's no I involved, so nothing. They are not taking part in summation. They are just constant. They are multiplied in every term of the summation. Okay. We have MCI, and if we multiply n factorial, am I right? Am I right? Sorry, yes, n factorial upon this will n plus I minus p, which we can write down like this: n minus of p minus I. Okay, this into 1 upon p minus I factorial, p minus I factorial, right? Interesting. Now we have multiplied n factorial, so we have to divide as well, n factorial. So far so good. So we have, finally we have n plus p factorial upon p factorial n factorial into summation of MCI into, and what is this? This is nothing but NC p minus I, p minus I. So far so good. And if you know, if you have studied binomial theorem, and if you have studied, series where we have to find out, series involving product of two common two C terms. Okay, two type of C terms where the lower subscript have summation equals to some constant value, and here we can see the summation of the lower subscripts are is a constant. It's p. I plus p minus I is p. So directly we can write down this. This is nothing but n plus p factorial, and we can write down this is nothing but n plus p cn or n plus p cp. Okay, into, and what is this? This is nothing but n plus n cp. Perfect. Okay, cool. Everything is so perfect because this I is, of course, this I is starting from 0 to m plus n. So we have basically covered all the terms. Okay. Now, so we have finally arrived at final expression, which was actually f of m comma n comma p. Now we have to find out what we have to find out g of m comma n. And this is an expression, the expression f of m comma n comma p is involved there. So let us use just that. Okay, p starting from 0 to m plus n. So g of m comma n is nothing but summation where p starting from 0 to m plus n. Here the term which is varying is p. Okay, and f of m comma n comma p, which is nothing but m plus p c n multiplied by m plus ncp, and I guess there was something in the denominator. Yeah, n plus pcp, n plus pcp. Okay, n plus pcp. Oh, that is wonderful, because you can see we can cancel out these two terms. They are same. This is n plus pcn, or we could have written n plus pcp. ncr equals to ncn minus r. These are same terms. Okay, and if we run the summation for p, what will we get? Oh man, this is so easy. Finally this has simplified to the easiest of term, which is nothing but 2 to the power n plus n. Perfect. Now we can answer any question regarding g of m comma n. The first option is what we have. First option, 2 g of m comma n is 2 to the power m plus n. Let us just write down beside the question so that we can mark it faster. So g of m comma n is nothing but 2 to the power m plus n. We can answer everything. G of m comma n equals to g of n comma n. If we interchange the order of m and n, it doesn't matter at all. So it's true, right? So this is true. Again, g of m comma n plus 1 equals to g of m plus 1 comma n. Is it true? Of course it's true, because this is in power, right? G of m comma n plus 1 is again 2 to the power n plus 1, which is same as 2 to the power m plus 1 plus n, right? So this is also true. Coming to the C option, g to the power 2m comma 2n will have Yeah, it's also true. 2 to the power 2m plus 2n, which is nothing but 2 to the power n plus n whole square. Okay, no, it's not true. Actually, it's option D. Okay, and option C is twice of g of n comma n, which is quite not true. Okay, so finally we have options A, B, and D. These are our answers. Okay, this was a multiple correct type. So here you go. Thank you.